Glasses, ceramics, and composites. Today's lesson, we're going to look at these three aspects. Now, I must say this is not very exciting. It is AQA specific, and it will involve a lot of rote learning. At Excel, people don't do it. I don't know why they make you do it, but you just need to know these facts, okay? I mean, it is a real life application, which makes it useful. I mean, everybody uses glass windows, etc., etc. So let's start with glass. There's two types of glass that you can actually make. You can have, so this sheet will be like the summary one. You can have soda lime glass or borosilicate glass. So if we look at the soda lime glass, that will be glass made from mainly sand. Now, sand is silicon dioxide, a giant covalent lattice, limestone, calcium carbonate, and sodium carbonate, known as soda, sodium carbonate. So the common name will be soda lime glass. Okay, how is the glass made? You heat up these three raw materials at 1500. Then the materials melt and they form molten glass. As they cool, they solidify and the glass turns to a solid. The pattern in the glass will be an irregular pattern. Side note, recycled glass is becoming more important and it makes 30%, making up to 30% of some glass making mixtures. So they're recycling glass, like your glass bottles. Now, as I said, there's different types of glass. There's a soda lime glass, which we just did. There's the borosilicate glass, which is essentially Pyrex glass, which you might have seen in these types of kitchen equipment. So this one is actually made from sand, silicon dioxide, and this time boron trioxide, B2O3, as opposed to using the soda mixture of limestone and soda, sodium carbonate. It melts at a much higher temperature than normal soda lime glass. So soda lime glass will normally melt at 573. This will melt at 820. The procedure is the same. You heat and melt these together, and then you shape them the way you want, the molten glass, and then you let it cool down. So it's the same method, it's different raw materials. So I guess to summarize this, it's actually very nice in this table. The sheet will be attached. So soda lime glass, these are your kind of raw materials, and that's what the use of it. And the borosilicate glass that's stronger is used in the cooking glassware and lab apparatus and is heat resistant. Whereas this is the most common type of glass used in the windows. Okay, so next we do the ceramics. So ceramics, what are they? Okay, so ceramics, they're not made from carbon. They're made from clay in a hot furnace, and they're used in bricks and crockery. That's the two main facts. So let's have a look at clay ceramics. So side note on clay. This is the revision guide. I'll attach all these documents. So ceramics are non-metal solids with high melting points that are not made from carbon-based compounds. Clay is a soft material dug out of the ground and can be molded into a different shape. So what you do is you fire it at a very high temperature and let it harden to form a clay ceramic. And you use it for pottery and bricks. Okay. Now, glass, theoretically, is a type of ceramic, okay? So ceramics, glass will fall under that topic because it's transparent, it can be molded, and it's brittle. Okay, and then these are the two types of glass we already did. So glass is a type of ceramic. It's not a composite, it's a ceramic. So let's look at general clay ceramics. So list the three general properties. They're hard but brittle, normally. They don't conduct electricity, and they're unreactive to chemicals. So you mold the wet clay into your desired shape at around 1000 degrees, and you let it cool and harden and solidify. So that is the principle of glass making as well. Now, clay can contain aluminium and potassium, and it contains silicon and oxygen, which are non-metals. Okay. There is some covalent bonding between the non-metals, and there's some ionic bonding between the ions. They normally form giant structures with layers. When the clay is wet, water molecules essentially go between the layers, and it makes it slimy, so you can shape it as it's spinning. When you put it in a furnace, what happens is the water molecules get driven out, and then strong bonds form between the layers in a giant structure, which then change the property dramatically. So they can harden and be used for bricks, make houses. Okay, so you're driving the water molecules out in the furnace, and that's what's happening. Why are ceramics brittle? So brittle means that if you hit them at a particular angle, the layer structure can essentially shatter. The reason is that they have an aspect of ionic bonding in them. So when you hit them, the charges used to be opposites. Now they're aligned with like charges. So plus and plus together, minus and minus together, which wasn't the case originally. So when that happens, they're going to repel each other. So that's the same reason why ionic crystals are going to be brittle as well. It's the same reason that we mentioned in the bonding topic. So that's what ceramics are. So glass, a type of ceramic. Ceramics also include other stuff such as bricks. Okay. And we've done polymers in a separate lesson. The last thing we need to look at is what composites are. Okay, so that's our last part. Now, if you look here, what's a composite? A composite is a mixture of a matrix, okay, a reinforcement material in a matrix called a binder. And the composite has different properties from each of the separate materials used to make it. So for example, let's have a look at fiberglass. Fiberglass has a matrix, which is a polymer, and the reinforcement is going to be the glass fibers. If you take concrete, for example, the matrix is the cement and the water, and the reinforcement is the sand and stones. You essentially need to know some examples of composites. So if I show you the syllabus extract on this, there's the topic, clay, ceramics, and composites. Now we did glass as well. But so glass is here. We've covered this part already. We covered clay. We've covered this before in the polymer topic, and we've covered this in the polymer topic for AQA. We've done high density and low density polyethylene and thermosoftening and thermosetting. Today, we're literally just looking at a small teeny weeny section here. So what's a composite? You need a definition, you see, so root learning. It's a matrix or a binder that's surrounding and binding fibers or fragments of other materials called reinforcement. Students should be able to recall some example of composites. So that is the ultimate purpose. Can you name some examples of composites? And that table had some good examples of composites. If I show you some more of these, so composites, I'll bring you something more of a picture, perhaps to help with this. So if we look here, Save My Exams, a good website. Composites, this is where I like to show you this picture here. Okay, so a concrete beam, okay, reinforced with steel, providing it with more tensile strength used to build buildings. So steel is going to be a reinforcement. Your matrix is all the bit around it, which is the concrete. So that way I would just learn these three. So concrete, fiberglass, which is glass fibers, are being used to reinforce a big polymer. Or you have the carbon tubes, which have these strong carbon nanotubes that connect the polymer resin. Okay, so just learn that composites are made of a reinforcement and a matrix, and know some examples. And know that they have different properties to the original materials. So for example, while steel and concrete are two different things, when you make the composite, the steel reinforced concrete has immense tensile and compressive strength, so it can be used in columns to support buildings. Carbon fibers are extremely strong and low weight, so they can be used in essentially spaceships and bicycles and planes. Okay, so literally it's a very small section. Just learn these key parts. It is in these notes as well. Here you have many examples. Okay, you just need to know maybe about 3. It doesn't specify which ones you need to know. And that's it. As I said, polymers was done in a separate section. And this completes the glass, the clay, ceramics, and the composite section. Okay, so good luck, learn through it, and see you next time.